This section is about inverse functions. That is, well, it doesn't always exist. The F inverse doesn't always exist, but F inverse written this way undoes F. So whatever x, F was given x, F sends it to f of x, and f of x sends it right back again. So F inverse of f of x is x, and f of f inverse of x is x. So they basically are out, they undo each other. So another way to say it is that y equals f inverse of x if and only if f of y equals x. So it reverses the roles of x and y. Now, if this were a graph of y equals f of x, then the graph of y equals f inverse of x will be f of y equals x rather than y equals f of x. And basically, this graph reverses the roles of x and y from this graph. Now, you can do that simply by flipping through the diagonal. Flip. And that turns this graph of y equals f of x into a graph of x equals f of y, or y equals, in other words, y equals f inverse. So they're symmetrical around the diagonal. Now, here are some examples of that. Adding 1 and subtracting 1 are inverse operations. X plus 1 minus 1 is x. Here's a graph of y equals x plus 1. Flip it through the diagonal, you get the graph of y equals x minus 1. Here's a graph of y equals 2x. And the inverse of multiplying by 2 is dividing by 2. So here's a graph of y equals x over 2. And again, you can get from the graph of this to the graph of this by flipping through the diagonal. Now here we have here like this. This is the graph of y equals x cubed. Here's a graph of y equals cube root of x. Again, the inverse of cubing. And you get from one to the other by flipping through the diagonal. Flip. So these are how graphs of inverse functions go. Well, there can be some problems with that sometimes. Because sometimes when you flip something on a function graph on a side, for example, y equals x squared, flip x and y axis, here's a graph of x equals y squared. It's no longer a function graph. It's really, it's two functions graphs. Here's a graph of y equals square root of x, and down here is y equals negative square root of x. So we do not have a single function inverse. We get two, and that's more problematic. So the trouble is that this function here is not what's called one-to-one. It sends two different numbers to the same place. A one-to-one function is if their two numbers are different and f of them are different. It sends different numbers to different places. That way we can invert. Gesundheit. So a one-to-one function is one that has, you remember the vertical line test, we're testing whether or not something is a graph of a function. This is not a graph of a function because it fails the vertical line test. We flip that through the diagonal and get a horizontal line test. Horizontal line test is that if every horizontal line meets the graph just once, then it's a one-to-one function and it has a single inverse. Here, however, this U-shaped curve like x squared, here it is not one-to-one. It sends these two to the same value, 0. And so inverse wouldn't know where to send 0 back to. So it's a horizontal line test. If you want to find the formula for an inverse, to write y, you write y equals f inverse of x. Therefore, f of y equals x, and then we do a bunch of algebra to solve for y. In a sense, algebra is one long inverse operation. So for example, the function f of x is 2x plus 4. What's its inverse? Well, we'll write y equals f inverse of x, so f of y equals x. So plugging in y in here, you get 2y plus 4 rather than a 2x plus 4. And this 2y plus 4 equals x. Now we want to solve for y. First subtract 4, so 2y equals x minus 4. Then divide by 2. Y equals x minus 4 over 2. And this is the inverse function to this. Now, an interesting little detail happens. If you look at how 2x plus 4 works, it starts with x, it doubles it, 2x, adds 4, 2x plus 4. the inverse, as you can see here, it starts with x and subtracts 4, it gets x minus 4, then divides that by 2, x minus 4 over 2, times 2 divided by 2, plus 4 minus 4. These inverse functions are reverse operations in reverse order. So if you do something to undo it, you have to undo each step, a step at a time, in reverse order. Okay. So in each of these examples, find an expression for f inverse. Your f is x over 5 plus 4 over 5, so find the inverse. So if y equals f inverse and f of y equals x, so y over 5 plus 4 over 5 equals x. And then let's multiply throughout by 5 and get y plus 4 equals 5x. Subtract 4, y equals 5x minus 4. So the inverse function is 5x minus 4. Okay, you can think of that if you put these x plus 4 in the numerator, so x plus 4 over 5, it first adds 4 and divides by 5. This one multiplies by 5 and then subtracts 4. Reverse operations in reverse order. Here's a function f of x equals 4 over x. Find its inverse. Y equals f inverse of x, so f of y equals x, so 4 over y equals x. So if we flip everything upside down, then you get y over 4 equals 1 over x, then multiply by 4, and y equals 4 over x. And what do you know? The inverse is 4 over x, just like the function is 4 over x. This function is its own inverse. 4 divided by 4 over x turns out to be the same as x. This happens sometimes. Here, f of x equals x cubed plus 8. To find the inverse, y equals f inverse of x. So f of y equals x. So y cubed plus 8 equals x. And to solve for y, we first subtract 8. Y cubed equals x minus 8. Then we take a cube root. Y equals cube root of x minus 8. That's the inverse. And again, opposite operations in opposite order. Here, x is cubed, and then you add 8. Here you subtract 8 and then take cube root. All right. F of x equals 2x cubed minus 3. To invert that, y equals f inverse of x. F of y equals x. So 2y cubed minus 3 equals x. To solve for y, we first transpose the 3. 2y cubed equals x plus 3. Then we divide by the 2, both sides. Y cubed is x plus 3 over 2. Then you take a cube root. So y equals cube root of the quantity, x plus 3 over 2. And that is the inverse function, cube root of x plus 3 over 2. All right. And again, it's fairly obvious. First you cube, then you double, then you subtract 3. First you add 3, then halve, and then take cube root. Here, f of x is minus 2/3 x plus 3. So if f of y equals x, then minus 2/3 y plus 3 equals x. So minus 2/3 y equals x minus 3. So y equals negative 3/2 of x minus 3, which you can rewrite as negative 3/2 x plus 9/2. And that is the inverse function. That concludes that part.